Good morning students. Now we can move to topic thermal aspect in machining. What is meant by thermal aspect in machining? This is the region of heat generation. Okay. The heat generation should be arrived with the workpiece material that is denoted as the thermal aspect. There are three regions in metal cutting where heat is generated. What is three region? Around shear plane, tool chip interface, tool work interface. The, the three region to generate the heat around shear plane. Initially, we have discussed about the around shear plane. During machining, plastic deformation of metal occurs on the shear plane due to which heat is generated. Okay, the heat is carried away by the chip because of which its temperature is raised. The remaining heat is retained by the workpiece and is known as primary deformation zone. The remaining heat is retained by the workpiece and known as primary deformation zone. Heat generated at the shear plane is due to internal friction and it is about 65 to 75% of total heat generated. Okay. Second one plays the region on tool chip interface. When the chip flow upward along the tool face, friction occurs between their surface. Hence heat is generated. This is called tool chip. Chip flow upward along the tool face. Friction occurs between their surface. The heat is carried by the chip, which increases the temperature of chip and the remaining is transferred to the tool and coolant. The area is called secondary deformation zone. The heat generated is 15 to 25% of total heat generated. Next one of the tool workpiece interface. Another source of heat generation due to friction is tool flank, which rubs against the work surface. The heat form 10% of the total heat generated. The heat is carried by the tool workpiece and coolant. Heat is carried by the tool workpiece and coolant. When tool is not sufficiently sharp, then heat generation in the region is more. The knowledge of cutting temperature is important because of affect the wear of cutting tool can introduce the thermal damage to machined surface and causes error in the machined surface. There are various methods of cutting temperature measurement as follows. Tool work, thermocouple. Circuit made by joining two wires of metal of work tool with a small mass to come to thermal equilibrium rapidly. Embedded thermocouple, radiation pyrometer, calorimetric method. Okay. Factor affecting the cutting temperature or application of cutting fluid. Best solution for temperature reduction. Selection of proper cutting tool geometry and a change in cutting condition as cutting speed and feed. Reducing cutting speed and feed reduces cutting temperature. This is called thermal aspect. Okay. Another we discuss about tool life. The tool life is defined as the cutting time required for reaching the tool life criterion or time elapsed between the two consecutive tool resharpening. The following are some of way expressing tool life. Volume of metal removed per grid, number of workpiece machined per grid, time unit. Factor affecting tool life, cutting speed, feed and depth of cut, tool geometry, tool material, cutting fluid, work material, rigidity of work, tool and machines. Okay. Functions of cutting fluid. It prevents the workpiece from excessive thermal dissociation. It improves the surface finish. It causes the chip to break into small parts. It protects the finished surface from corrosion. It washes away the chip from the tool. It prevents the corrosion of work and machine. Type of cutting fluid. Basically, two main type of cutting fluids: water-based cutting fluid, straight or heat oil-based cutting fluid. Okay. Method of applying cutting fluid. Cutting fluid are used in the many ways such as drop by drop under gravity, flood under gravity, form of liquid jet, atomized form with compressed air, through centrifugal action. Okay. Thank you, student.